lesson from yesterday. I should be able to finish with some time left in class. We'll actually get started on tomorrow's lesson already. That's why I passed out the packets. And that's why you guys had an extra one. So the goal would be, if we can somehow finish Monday's lesson before Monday, then we can go back to the original plan for Monday, was to have an activity. And yeah, so things would still be boring, but maybe it will be less boring. Maybe. You'll find out on Monday. Okay, I guess we found out already. I think I told you yesterday.
I just have that.
All right, so here we go. Let's continue. The first example on the left is from yesterday. They want a similarity statement. Well, we have to first decide if the two figures are similar and then write a similarity statement, a statement of proportionality, a similarity ratio, and a perimeter ratio. Sweet. All right, the first one on the left, this problem A. Yeah, that's the first letter of the alphabet. If those two are to be similar, because now, even despite the fact that they're asking us for these, if you're reading directions, we're not being explicitly told that these are similar. We have to decide if they are. So if they are going to be similar, what would we have to use in order to prove similarity?
Yes.
Yeah, side angle side. Because they're only telling us that one pair of angles is congruent, but they are giving us information about all the sides. So that angle, what was the word, the adjective that's used to describe the angle in between two sides? Included. So we'd have to then look at specifically the two sides that are next to those angles. And it looks like this has undergone at least a rotation, maybe even a reflection. And it looks like just a rotation. So in order to make sure that we pair up the corresponding sides, we'll look at what's bigger and what's smaller. So on the left, let's go with the smaller ones first. What's the smaller side on the the 12? That would have to correspond to the smaller of the. No, not the 12, the 4, yeah. So 12 divided by 4 would have to be equal to 18. No, there's no x. If this is true, then the triangles are going to be similar by side angle side. If this is not true, then they're not similar, therefore we can't even answer the rest of the questions. 3 divided by 4 is 12. 12 divided by 18 is 1.5. Huh?
How did you get those?
I did both. Yesterday I cross multiplied. Today I did it this way. Watch, let's cross multiply. But who's the one that asked that question? Who asked if you're supposed to? You didn't ask that. It came from, yeah, here you go. That's a good question.
I asked the question. I was like, why?
In order to determine if two fractions are equal, one way, both numbers, one way is to actually divide. But yes, and obviously these are not equal. But another way would be to check the cross products. As Alfred said, if I check the cross products, 12 times 12 would have to be equal to 4 times 18. 12 times 12 is 144. And then 4 times 18 is 72. Again, obviously not equal. So then these are just not similar. Therefore, we can't answer any of the subsequent questions. Anything for you, Kenny? Okay, for the next one, are those two similar?
Yes. Yes.
Yeah, why, Josh? Yeah, those we already know they're similar by angle. Angle similarity is a shortcut. It's enough to prove it, so we can't complete a similarity statement. We'll pick what to call the first triangle. We'll just go in alphabetical order, so I'll call the first triangle P, Q, R. The similarity symbol is like that little mustache. If you're familiar with the Spanish language, it's the little symbol that goes on top of the Nye. Yeah, I want to say it's called an tilde. An tilde. Jair, are you thinking about fighting crime on your spare time? Because I see you like with the hood on, and if you had like a matching cape, that'd be nice. You can just take it off though. All right. So which angle corresponds? I didn't say much. Which angle corresponds to P? B. I get it, why, but maybe not everybody does, so that's why I want to go extra slow. Symbol. For the Q has two arcs, yes, that corresponds with T, and then finally the S is at the end. So that's a similarity statement. A statement of proportionality. What's proportional in similar figures? Hard for everybody to hear when you guys are talking too. I finished a similarity statement. How did we go about finishing a similarity statement? Really, the easiest way is to compare angles. So the first triangle, you name it however you want, but just make sure that the second one falls in line. So since I chose to list P first, then on the next triangle, I'm going to write whatever angle corresponds to P. P has one arc, V has one arc, so that went first. Okay. The Q goes with the T because both of those have two arcs, and then the R goes with the S because those have no arcs. Okay. The next question says a statement of proportionality. So my question was, what is proportional on similar polygons? And he said sides, which is correct. So what I want to do here now is compare the sides that match up. I don't know, since I have a similarity statement, I don't even need to look at the diagram. So like, let's say the first one I want to call, and actually let's do it here to have more space. I won't have enough space there. PQ. What does that correspond to? PT. If I were to divide those two, and actually you can because they give you the length of all those sides if you wanted to, that should be equal to, let's go say QR. What would QR correspond to? It would be TS, and then finally that would correspond to the last two, which would be PR, and that would be BS. Yeah. That's a statement of proportionality. If you want to test it out, feel free on your own time. Go divide PQ, which is 9, by VT, which is 6. That gives you 1.5. So all of these should also give you 1.5. The what? Oh, maybe because you're joking too much. Luckily, this is all on video, so you can just go back and watch it tonight and write everything down. Similarity ratio. What did we call similarity ratio? Good. That's just another way of asking for a scale factor. And I'll let you. Oh no. Oh. Too bad I didn't get that on video. I'll let you in on a little secret. Perimeter. Since perimeter is a one-dimensional distance, it's a length. It's not like an area or a volume. It's going to abide by the same scale factor. So once you find the similarity ratio, that's the same thing as perimeter ratio. They're both going to be the same. Perimeter is just the distance that happens to be going around. If you were to divide the perimeters, you should get the same as a scale factor.
So that's the inside
of the outside. Yeah, when you're searching the perimeter or something, that's the outside. Area, interior. Yeah, area, interior. You learn something new every day. And they say public education doesn't pay off. Well, and actually, I already gave you the similarity ratio. I already gave you the scale factor. What's it going to end up being? Yeah. Now, nowhere here does it say what's the pre-image and what's the image. Like, they don't tell you what's the before and what's the after. So I got that 1.5 because I did 9 divided by 6. So, I could have also put 3 over 2. That's fine. Actually, I prefer that because ratio is a fraction. So I prefer to write it as a fraction. But if you would have said 6 over 9, that would have been fine also. But then I would reduce to 2 over 3. Here, watch. If you look at the rest of them, let's just look at the rest of them just for argument's sake. QR and TS. QR is 12. TS is 8. Take a while. Guess what happens when you divide 12 by 8? Yeah, you get 1.5 or 3 over 2. If you would flip them around and do 8 over 12, you would get 2 over 3. The last two, PR and VS, that would be 15 and 10. Take a while. Guess what you get when you divide 15 by 10? Yeah, 1.5 or 3 over 2. So the similarity ratio is the same as the parameter ratio. If you were to add up all the sides and divide them, you get the same thing. Aight. Mickey, any questions? You don't have the notes from yesterday? Thanks, Kenny. You let me know when you're ready. Okay, so here they want you to solve for x. X is associated with a side. Sides of similar polygons are? Who said it? So, in order to write a proportion, first I need a scale factor. They give us a similarity statement, so we can just double check, like they're giving us DF. DF are the second and third angles, so that would correspond to KL. Are they giving us KL as well? Yeah, 6. No, KL is 6. So my scale is going to be 9 over 6. That could be reduced to 3 over 2 if you wanted to. If they were only asking you for the scale factor, if the question said state the scale factor, yes, you would not receive full credit if you left it as 9 over 6. You'd have to put 3 over 2. Simplest form. But now this is not asking us for the scale factor. This is asking us to find a missing side. So 9 over 6 will work just as fine as 3 over 2. You'd end up with the same thing. What's going to correspond to the 9? Well, since the x is part of the same polygon with the 9, I want to put the x on top. I want to line it up with the 9. Remember I gave you the analogy, no pun intended, of using analogies. It's okay, Kenny. It'll come to you one day. How proportions can be compared to analogies. 9 is to 6. You don't want to put the 6 even, the x even with the 6 because they're part of 2 different polygons. Now, what corresponds? What can I compare the x to? Yeah, the 2. So 6x is equal to 9 times 2. 6x is equal to 18. So x is 3. Done. Cross multiply, yeah. Same thing. You say tomato, I say tomato. How about if the numbers didn't work as easily if it wasn't as conducive to mental math? That's what proportional. Remember, like we started off with dilations to show that figures that are similar occur as the result of a dilation. When you perform the dilation, what operation were you performing? You were multiplying, right? So yeah. Well, yeah, but dividing is the same as multiplying by a fraction. So when you express dilations, you express them in terms of multiplication. If you multiply by a number greater than 1, it's an enlargement. If you multiply by a number less than 1, it's a reduction. So yes, all that's happening here is multiplication. So like what you're asking me is, all right, well, hey, there is another way to set up the proportion also where instead of making the corresponding measurements from one polygon to the other, you could compare measurements from within the same polygon. So you could say, hey, 6 or 2 is 6 divided by 3, so 9 divided by 3 is 3. You're doing the same thing that's on the board. It's just you're just doing it, you're doing it mentally. I can show you in writing what you just did on the board. You did 6 over 2 is equal to 9 over x. Notice the cross products. What's still across from each other? The 6 and the x. What's still across from each other? The 9 and the 2. How about if the numbers weren't as conducive to mental math? How about if that would have been like, I don't know, 216 and like 72 instead of 6 and 2, you know, you would have. The only difference between what you did and what's on the board is that you either use mental math, which you probably did because the numbers are small, or you might use a calculator. But it could be written. It could be shown. So if anything, you know, agree to disagree. Like it's the only thing you're advocating is being able to do it without showing work. That's the only difference. You're not actually doing anything different than what I'm doing. It's just that you're doing it without putting it on the paper. It's the same thing. What you're doing, I could show it. It's the same thing. All right, word problem. Find the length of the model to the nearest tenth of a centimeter. They don't tell us that they're similar, but you know, I guess it's safe to assume that they're. I guess because they're both cars, they're assuming that both of these are. Okay, this is a racing car. This appears to be a model of the same racing car, even though it's not painted the same. And models, like little toy cars, tend to be to proportions. Okay, now this is an interesting one also because now we're throwing in units. And you got to be careful with mixing units when you write a proportion. Okay, now as long as the measurements line up, you know, like kind of like an analogy, remember dog is to bark as cat is to meow, then you can get away with mixing measurements. So watch, let's do a scale. What would be a good scale to use here? King Henry, no, King Henry's not going to be a scale. What would be a good scale to use? What are the pair of corresponding measurements that we are being given both of? All right, so fine. Let's just do 1.8 over 6.3. But notice how the 1.8 is in meters and the 6.3 is in centimeters. As long as the next fraction is also meters over centimeters, then you're fine. If the units did not line up, then you can't use that proportion. So when I go and write my other fraction, we want to know the x. The x goes with the 6.3, and whatever I end up getting for x would then have to be in centimeters. And then, yeah, what corresponds to the x is 5, which is in meters. That's good. So both fractions are arranged as meters over centimeters. So that'll work. Addy, you want to do this one in your head? No? You can probably use a calculator and it'll work. It'll work, but just why not do it this way? 1.8x is equal to 6.3 times 5. 1.8x is equal to 31.5. Thanks, Scotty. Is that going to also be a decimal? 31.5 divided by 1.8? Yeah. Probably should be. Does it go on forever? Does it truncate? So x is equal to 3.9375. Yep. Okay. Be careful with these. A lot of times, these type of problems on standardized tests will tell. See, perfect. Look at that. I didn't even read it and I knew it. I've done so much of these that they're actually telling you to round. So to the nearest tenth, what is going to be the nearest tenth? 3.9. Yeah. So this changes to that. This changes to a little squiggly line. Wavy. Because that means approximate. That tells the person reading it that you rounded. Your mind's being. See what happens when you stay awake? Good things happen when you stay awake, man. Yeah. First you get Shaughnessy sitting next to you. Then you learn about approximation. I forgot what it was. You learned something else before too. Things are going his way today. Solve for both variables. Like if I would have written this problem, I would have stated that these are similar triangles. We actually don't have enough here to prove similarity, but we'll just assume similarity. This is not, we wouldn't be given this. We need a scale. What can we use as a scale? Yeah, you can do 6 over 4 over 4 over 6 if the question specifically asks for just the scale, Dakari. Don't leave it like that. Leave it and put it in simplest form, which would be either 2/3 or 3/2. But since we're just being asked to solve for an unknown, simplifying is you can get away with it. It's not a big deal. Let's find x first. What does the x correspond to? Let's see. So yeah, it's gonna line up with the 6 because the 6 that you're seeing is this 6 here. X is part of that triangle, so this x will go on the bottom. And then what measurement in the other triangle does that happen to correspond to? 6. Let's do one for the y. I'm gonna use the same scale, 4/6. The y is also part of the bigger triangle, or what appears to be bigger. So I line it up with the 6, but then what does that correspond to on the other one? Little triangle, big triangle, little triangle, big triangle. 4x is equal to 6 times 6. 4x is equal to 36. X is equal to 9. Cross products. I'm going to draw the arrows for you. That's what I'm multiplying. So here it's going to be 4y is equal to 6 times 8. 4y is equal to 6 times 8. So 4y is equal to 48. Divide by 4 like all the cool kids do. I'm not going to fall asleep anymore. Any other questions? How are you doing back there? How was practice this morning? How bad? Here, why don't you guys do this one? Raise your hand when you got an X, and then raise your hand when you got Y. All right, Hattie, give me X.
Yeah.
That sounds all right. I'll take your word for it. Somebody give me Y. Somebody else. It's a trick question, but it's not even a trick question. It'll take you about half a second to find why.
16.
Okay. Here's another one. Why is it 16?
Because it's parallel to it's parallel to 16. It's corresponding to 16. It's corresponding to 16. Corresponding. Opposite side.
Why?
Opposite side doesn't grow.
Why?
I mean, it's
Parallelogram. It is a parallelogram. I just like Josh better than everybody else. So. Let's find X. Yeah, for X you did need if they don't give you the opposite side, you did need a scale factor. So 12/16 is equal to the X would go with the 12, and that would correspond to the 28. So 16X is equal to 12. Huh?
You said.
Sorry. But I wrote 18 though, right?
Yeah.
Thanks, Kenny. 216, yeah. And then divide by 16, and how do you say that was 13.5? Yeah. And how do we trust? Awesome. Any questions? Last one. Ooh, these are fun. These are always test questions. I don't know. These are almost like well, basically multiple choice. So, two right triangles are similar. Is that always, sometimes, or never true?
Sometimes.
Sometimes. Why sometimes? Yeah, well, if they're both right angles, they have one pair of corresponding angles that are always going to be congruent. Do they have a second one? Well, they might or they might not. And it can't be never, because you have at least one pair of corresponding angles that are congruent, but that would be sometimes. It all depends on whether or not another angle is also congruent by angle. Two squares are similar.
Nope. Never true.
Yeah. Why is that? Well, think about it. In order to be similar, remember on the notes, if you still have them, angles are congruent. And yeah, and remember the only types of polygons that we have shortcuts for are triangles. Okay, so anything other than a triangle, you'd have to actually show that all of the angles have a corresponding angle that's congruent, and that all the sides are proportional. Sides are proportional. Okay. So with a square, well, we know that the angles are taken care of because every single square is going to have what types of angles? 90. Yeah, everything's going to be 90. So the question is, well, would the sides be proportional? But what do we know about the sides of a square? The sides.
They're parallel.
Seriously? Like if I asked like a third grader what they know about a square, they would tell me, what do we know about the sides of a square? Yeah, they're all the same. They're congruent. So even if I have two different squares with two different sizes, give me a number, buddy. Quick. Huh? 12. So here you go. 12, 12, 12, 12. That's true about that square. Give me a number bigger than 12. 4. All right, 75. 500. Guess what? When I divide 75 by 12 the first time, am I going to get something different than when I multiply 75 by 12 the second time, or the third time, or the fourth time? I'm going to get the same thing every time. Okay, a parallelogram and a trapezoid are similar.
Never.
Why?
Trapezoid. Wait, number 10?
Oh, because the trapezoid has only one side.
It has a parallelogram.
I mean, no, it has no side.
Are you guys asking me or are you telling me? Because I'm kind of, yeah.
There's no side.
Now, this is a little bit out of sequence because Monday we were supposed to cover trapezoids, but because of the little hiccup with the test, that caused us to have to test on Monday.
It can't be parallel.
Okay? But when we do cover trapezoids either tomorrow or this coming Monday, you will find that unlike parallelograms, trapezoids only have one pair of parallel sides, not two pairs. So what that causes is now you cannot, you cannot have opposite angles be congruent. And I mean, if you were to follow that down a little bit further, it's going to be impossible to have all four corresponding angles be congruent to all four corresponding angles of another one. And that's not even mentioning anything about the sides.
Wait, which sides are?
What are called the bases. Yeah, the trapezoid has two types of sides. One's called the bases, one are called the legs. The legs can be congruent, but they don't have to be. The bases can never be congruent on a trapezoid. But we'll learn that on Monday. If two polygons are congruent, they are also similar. That's actually always going to be true. But the converse is not true. If two polygons are similar, they're not always going to be congruent. Because in order to be similar, only this has to be true, right? Okay. Let's go back to here. Let's do rectangles this time. Okay. So if the polygons were to be congruent, yeah, here they happen to all be 90, but even if I were to draw a pentagon, the fact is that two polygons are exactly the same. Are their angles going to be the same? Yeah, at least the corresponding ones would be the same. So the angle is taken care of. And would the sides be proportional? Well, if all the sides match up, yeah, when you divide, you're going to get the same thing. The only difference would be on congruent polygons. When you do that division that we did up here, when you do this type of division, not only are they going to be equal, they'll just be 1. You're always going to get 1. Because if they're the same, what's anything divided by itself? 1. Yeah, you always just get 1. 1 is equal to 1 is equal. Make it even more briefcase. All right, let's show it. Yeah, let's not do let's do some weird looking quadrilateral. There you go. Almost looks like a trapezoid. Magic of technology, I'm able to replicate it. And let's say this is 80. This is 95. This here is going to be, let's say, 140. So that's so then this is 55. Does that add up to 360? Did I do that right? 150. 150 and 220. Now 124. Let's say 45. I think that will work. I think I carried an extra 1. Patty, you're my fact checker. Does that add up to 360? So I said 80, 95, 140, and 45. Okay, adds up to 360. Does every angle have a corresponding angle that's congruent? So, yeah, that's true. Yeah, that would be because they're actually congruent. Like I actually just hit copy and paste. No, I'm just kidding. I'm a really good drawer. I just drew the exact same thing twice. No, I'm not a good drawer at all. So and then let's say this is 10, 18, 23, and 6. So 6, 10, and let's say it's centimeters. Are those sides proportional? Well, sure, because when I divide the corresponding one, what's 10 divided by 10? 1. What's 18 divided by 18? 1. What's 23 divided by 23? 1. What's 6 divided by 6? No, Kenny, it's 1. So of course, yeah, anytime polygons are congruent, they also have to be considered similar. Kind of the same thing as like comparing rectangles to squares. Is every square a rectangle? Yes, because everything that's true about a rectangle is true about a square, but just the converse isn't true. Not every rectangle is a square, but every square is a rectangle. Yeah. No, I don't want it.
What's 2 and 2 put together?
I have 22.
22.
Thanks, Jair. Two coins add up to 30 cents. One of them is not a nickel. How?
10 cents and a quarter and the 5
I got the answer. Wait. You said 33?
2 coins add up to 30 cents. One of them is not a nickel.
I know what it is. It's a quarter and the 5 cents.
A nickel is 5 cents. Are you okay? Cut the 25 cents.
$2.
Alright, I'll let you think about it. You can tell me later. Alright, let's finish. I'm gonna finish.
$2 and 10 pennies.
Yeah, you cut the 5 off the 20. Yeah, you gotta cut it off again. You gotta cut the piece of 25 out to where it equals 20.
Can we finish? If two polygons are similar, they are also congruent. Very good. Yeah, that would be something.
It's a down picture.
So the reason why it's sometimes is because I just showed you an example where it's true, where you can both be similar or congruent, but really this is the only time that it's true. This is the only time, so that would be sometimes. Yes, Jair.
It is a quarter and a nickel because it's not one of them.
You just said
It's the opposite one. Exactly. Be quiet, child. Exactly.
like what?
Hey, this ain't no interception town. Get my candy again, man.
That's crazy how that's like
One of the coins is not a nickel. The other one is.
I thought you said two.
Hey, but guess what? Who got the candy? You know.
There you go. All right.
If we answer what I answer with,
Hmm?
a dime
All right, can we try to get through this as much as possible so Kenny can have his Kahoot on Monday? So tomorrow's lesson was supposed to be on parallel proportionality theorem. I can get through this first page pretty quickly if you allow me to. What word do you somewhat recognize up in the title? Yeah. Well, okay, I take it back. Yes, I'm sure that you do recognize that. You should definitely know what parallel lines are. But as far as more specific to what we've been doing, proportion. Okay. This lesson revolves around the ability to write a proportion, but now the proportion is new. Instead of having what on similar figures, what is proportional? The size, right? Well, now what this theorem tells you is that if you draw a parallel line through a well, actually should also work with trapezoids too. But well, we're gonna deal with it with triangles. If you draw if you get a triangle and you draw a line that's parallel to one of the sides that it's touching, the sides that it's crossing, are broken up into however many parts. In this case, it's broken up into two parts. Part one, part two, part one, part two. But this even works if you were to draw several parallel lines. So what this tells you is that the parts of the side, the little sections that are across from each other, those are also proportional. The little sections are also proportional. Okay, so like if you remember on yesterday's notes, so look, I do have yesterday's notes available because we just went over them. And I think I even alluded to this yesterday. There was a diagram that was given to you at the beginning that looked like this. Okay, and at the time I said, hey, look, if you need to find the missing side here, split these up into two. Now that's still going to be true if something that you're looking for or being given has to do with these sides here. But if you're looking laterally on the like the sides where the parallel line is touching, if I'm missing any one of these measurements here, I don't need to split up the triangles. I can just set up a proportion comparing those measurements to each other. That's the basic gist of the entire lesson for tomorrow. So, if I'm missing anything, yeah, it's the same thing. So here we can go straight to the examples here. Verify that DE is parallel to BC. So we want to know if this is true. If this is true, these little sections that are across from each other should be proportional. So we can set up a scale. Set up one and I guess we wouldn't even count as a scale here because we're not looking for an unknown. Let's just set up the first fraction. Let's set up a ratio. Kenny, what do you want? Okay, so one thing you cannot do. Out of all, you could have said almost anything like that, and you would have been right, but that's the one thing you can't do. You can say 8 over 10, 10 over 8, 12 over 15, 15 over 12, but you can't go across like that. Charisma, I'll let you. You've been quiet today. Strangely quiet. Give me a ratio. Give me a fraction. 10 over 8, fine, fair enough. So if Charisma decides to go 10 over 8, what does she hit now? The second one, she doesn't have the option. She has to fall in line. What would be the next fraction? 15 over 12. Alfred, you could either just divide and see if you get the same number. I normally stay away from that because that could lead to like decimals that fill up your screen. But I did it on that one other one because I knew I could do it in my head. But the safer way, if you want to do the cross products, 10 times 12 would have to be equal to 8 times 15 in order for those lines to be parallel. 120 is equal to 120. All the children then rejoice because now we've just proven that the lines are parallel. Because parallel proportionality theorem applies. Is that your parallel dance, Jair? You have a parallel dance? Oh, that's why you wear the hood, so you can hide the headphones. So I asked you to take the hood off, man. Yeah. Shh. That's actually what I just told him. Simplifying the fractions accomplishes the same thing as dividing. If you did not want to cross multiply, like watch, you have a calculator out, do 10 divided by 8. Yeah, you simplified it to 5 over 4, and the other one also would have given you 5 over 4, but just divide. 10 divided by 8 is? Okay, do 15 divided by 12. So, you kept it as a fraction. I told him he could do it as a decimal. It's the same thing. Instead of cross multiplying, you're just comparing to see if both sides of the equal sign are the same. Works the same. Any questions on that one? Okay, next one. Again, verify. Instead of labeling everything here, some of the information is given to you in the statement, so I would label. Okay. If AC is 36, well, I don't want to know AC. I want to know AD, it looks like. So if from A to C is 36, how would I know what AD is? Kenny, you are on fire today, buddy. You woke up on the correct side of the bed.
We have one side.
Oh yeah, that would be rough if you walked into the wall in the morning and you rolled into it. That'd be kind of weird. That'd be even worse. That would be funny, but it'd be worse. All right, and then BC. Yeah, but I don't want BC. I want BE. So how could I then find BE if I'm being given BC? Yeah, subtract again. 27 minus 15. That's 12. So now that we have this set up, are you trying to be like Jair? Mm-hmm. Instead of wearing the hood, just get like friendship bracelets. 16 over 12. We can't all be leaders. Sometimes there's something wrong with following. So now let's check if this is true. Natalie, if you want to reduce, great. Fredo, if you want to divide, that's fine. But you can also cross multiply. And let's see if this is true. This is 240, right? This is not going to be 240. Yeah, it is, yeah? Color me embarrassed. Yeah, at the same time, 30. 240. So, yeah, those are verified. Any questions there? I can do one more before we go. Ooh, okay, so yeah, this one they call it extended parallel proportionality theorem, but I guess that's if you want to know the name, but it works the same. Let's find LM and MN to the nearest 10. Okay, so now since we're actually finding something, we do need a scale. We need one pair of corresponding measurements that we could always use in a proportion. Do they give? It looks like it's going to have to be the one with a 2.6. What does 2.6 correspond to? 2.4. So I'll say 2.4 over 2.6. That'll be my scale. If for some reason they were only asking for the scale, I'd have to simplify that. You would just move each decimal one and then reduce 24 over 26. Give you 12 over 13. LM. So LM is part of the bottom. That's where the 2.6 is. So I'm going to line that up with the 2.6. And then LM corresponds to 1.4. The MN is also part of the bottom. So when I find that, I'll put that even with the 2.6. And then that one goes with 2.2. I'll stop there. No, it's not the answer. I'm not done. I'd have to cross multiply, but yeah, I'll do it quick and then you can just watch it at home. 2.4 times LM. Has anybody even watched one video this year that I've ever done?
Yes.
What's somebody help me with the calculator? 2.6 times 1.4?
36 point or 3.6.
3 point?
Wait, what is it? 1.4
times 2.6 times 1.4.
Yeah, 3.64.
3.64 divided by 2.4. Ooh, no, they have math print on. We're starting with decimals, so let's leave decimals 1 to the nearest 10.
I got a syntax error.
1.5? So it's approximately 1.5. And then 2.4 times MN is equal to what's 2.6 times 2.2? 8? Is it really that much? 2.6 times 2.2? 2 point, that sounds like too much. 5.72? And can that be divided by 2.4? Rounded? Or rounded 2.4. Alright, so tomorrow we can start off with the next example. We don't have too many more. And then we'll go on that way.